Okay, good morning, Tasha Delay.
Tasha Delay.
Can everybody see me?
We can see you.
All right. And you can
just
hear
a
me?
minute. Let me put you on the mic, then you can start. Now everybody can hear you as well. They can see you as well as you can hear you.
Okay, good. All right, well, good morning, everyone.
Good morning.
This is year one. We're today, during our 2 lessons, we're going to learn a little bit about gravity. So let me just introduce myself. My name is Justin Burton, and I am a professor here in the physics department at Emory University. In fact, my office used to be next to John Malco's.
Ne sama distillers tadi ngaso sotani kapsi bana ngaso tensigo kola ya ngotoji yes ane ngara me la ya Justin yes ane tanda nga Emory laptop ye ane ngin kam senrike den senange ane lopenji yes tanda ane ngoma bana ngarange lenkonte ane gen joma ko lenkon tandam la yores.
And I've actually participated in the ETSI program three times in 2015, 2017, and 2019.
Ngara imbana Emory project senri leram na la ya Thomas simji zishi jinyon yes niston chonga tan niston chudin tan niston chugu la ya zishi ji yes.
And so it's too bad we can't be there in person this year. I really enjoyed my time, but I'm happy to be here today to help you learn about gravity.
Ane ju tanda ta mi pa ngus chama ko de samba chu ra chire sha simbana yang ta tire ngarang dos chezula ane tenshu ko lo don cha la ya dos ju pentropy wa chi chin dos screens.
Okay, so I'd like to open the lecture today just by asking this question, and hopefully I get a few responses. Please tell me 1 or 2 things that you know about gravity.
Ane tire lam chen gu zu sta bala nge tro chi ga ne gu zu ge nge rewa imba na che su ge ane de ko la ya ane lang kha chi de we ge ro ta chi gi yes ne che su ge tenshu ko la kari sing ge yunas.
Nobody raise their hand? No, nobody knows anything about gravity?
Tenshu ko la kari sing ge na chi son ro chi da.
당저 사이 텐슈기 골라가서 명하지요. 명하디 그래서는 F equal to G 아니 M1 아니 M2 by 아니 D square 디 명하디 골라.
He's talking about the formula for gravitational force between 2 bodies, 2 masses. F is equal to gm1 into m2 divided by the distance squared.
Yeah, I was actually able to understand that one. That's great. So that's one of the first things we're going to start with today. But we're also going to try to, talk philosophically about gravity as well.
That and chitis love stambala shinshi son stitanga zu tirin tamsen gutsu yagi chu shinzen sati do an gutsu chin de shijagins and te gan la yang zu tenshu se te ge ne ko tatub ge chane yang anguto chigins.
Okay, so within gravity, the idea is the following. If I have any body that has some mass, some amount of kilograms, and another body, this is mass 1, this is mass 2, they will attract each other.
Ta ke ti ngara la ya nyu po ti do nyu pa pa na nyi po nyi je nyu po chi ge de sala m1 chi shen da de de sala m2 in ba na ne khora ni ga pa ro la ya ani chi thya ya ge shu chi ani ngong go res.
And it's not just those bodies, it's every molecule in this body attracts every other molecule in this body.
다 단단 가지고 기세 시험 스tambalaya 그 도도 좀 많이 바로와 단다 M1 요사긴 요보 때나나 요 비긴 뒤데 레레레레레레 그거네 아니 파조 M2 나나 요 비긴 요보 때게 양 뒤데 레레레레레네 도스 탱그레스
And it's not just that. Every molecule in this body attracts every molecule within that body too, which is why it's round.
다 단다게 시주티 쌈마임 바 단다가 소응이 보연 쇼응이 보티 나타반바나 연 쇼응이 보티 나라 요 비긴 뒤데 레레게 아니 쿠나나 요 비긴 뒤데 셴다 차마야 도스 탱게 레스코 초라 제자 아니 단다가 소응이 보티 리리바 강무요 레스
And so, in some sense, physics is the idea that the world is understandable. And it's often understandable in terms of mathematics.
따다들이 영으로 전생가리 시스템 발아야 가지고 있는 감당인 감그 세령 유부가 내리지어와데 아니 그 학고 투바당로와 학고 투바디양 간다사고 그래서나 양고 앙즈기를 받디 배치당데다 학고 투바게 내던데 정도요레스
So I will try not to write down many English words, but here all this word says is attract.
다 단다 임바나게 지 인지 값소 뇽뇽 지하게 답시당게 인스타 단다 지샤주 띵고 보니가 바로라야 판순 탱그레세 판 템바지고와 어때지예스
And so if every single tiny piece of mass in the universe attracts every other tiny piece of mass in the universe, we want to know how they attract each other and how to describe that.
다 직단 감라요 비기 뉴부 총총 창마게로와 소소문이 아니 뉴부 춘춘 차 현다 차만도스 탱기요 바인바이나 내가 쭉 그때 아니 딱 지금 즈기 다른 배치 당대때 아니 그 텐슈 그걸 주고 바로 그 텐슈 때 네 첨벌짓 그래스
And so let me erase this. And so if these two bodies are separated, the centers of these two bodies are separated by a distance r, then the force between them obeys this law.
다케티 뉴보든 체체로 뉴보든 체가 바로게 잔타티 아리바이나 뉴보든 바로게 텐슈지요와 니 텐슈티 올라 텐주게 텐션디게 아니 토토 첨버지요레스
This is Newton's universal law of gravitation.
다 디밀라 가스그레스나 뉴턴기 용체브기 텐식 텐션스그레스
There are two important pieces of information that we're going to talk about today contained within this formula here.
다 단다기 냠츠지요로 냠츠 진드되게 나라 맹간되게 나라야 아니 그 네tonke 침보니 직수고요레스와 네tonke 침보니 직수고요 버테 티랑가 숨고치기스
The first piece of information is that the force is the product of mass 1 multiplied by mass 2.
다 그런 거는 게다 지금 니츠스나 네톤스나 니츠 땅보티카레스나 슈데 아니 그게 뉴보니게로와 뉴보니게 뒤속에 주토던데요레스 테레스
And so this is saying if I have twice as much mass, for example, then I get twice as much force.
다고 샤잘라도 다 테켄도 예자로 디게 가르세고레스나 게티 나랑라요 뉴보게 뒤세티 답니스키 초요 바이나 네텔라 템비기 슈테양 답니스키 초요 같은 거레스
And so one thing is, please interrupt me if you have any questions.
다 게티 체술라야 좋아요 바이나 바로바로라 야 게티 주고 개바이나 야 전단안에 그다 참사지 샤제 드로트
This one's kind of easy though, right? I mean, we already understand this. For example, if I have a scale and let's say I put some, I buy some mangoes or some other fruit at the market, I can weigh these. There's a gravitational force pulling down, and the scale will tell me what is the weight of the object I put on the scale.
다 비자샤나가라스 톰라나 송에 다데게 샨토 암 다브게 샨토 테네로 카시 뉴 파임바나 땡아 수게다 자마나 주 파임바나 자마게 아니 거리땡그레스나 텐슈 라테네 땡 코게다 지세카 수치오 메치오와 땡아 술라야 땡고요레스.
So what you're looking at is the gravitational attraction between the Earth and these pieces of fruit.
다 단다 체랑게 지금 다사테 가릴라타고요레스나 아니 스쿨라기 텐슈다 아니 신도 두 바로 기타 데저 지고 바로 기 드와치고와 데저 텔라타고요레스.
Now, there's three pieces of fruit here on this scale. If I were to put 6 pieces, how much would the reading on the scale increase by?
다 게티로와 담보가 줄라 숨시오와 티강라야 양생아 속에 니신도 숨도지 내바이나 신도 숨내바이나 아니 자마강라야 고게다 지세칭고야 지고와 지세티 가츠치기 퍼서비스.
It's a question.
다지 바래.
Yeah, twice.
Twice, right, of course. And that's reflected here. If I put 2 times as much stuff, the force increases by a factor of 2.
이 다른 자리에서 답게 발그레스로 다가 수가 담니 차그레스 거와 다티 차그레스 가르치라 바이나 게팅가 샤자 단다게 냠츠티게 나라야 뒤세티 답게 파와인 바이나 다담니스로 담니 파와인 바이나 이 바조테야 담니 차그레스 다데 답게 파와이나 바조타야 답게 발그레스.
Okay. Now, I haven't mentioned this big letter G here, and it's important, but not as important as what we're talking about. G is called Newton's gravitational constant.
다 단다 데 값은 아주 달로라 지 첨부치 도가데 가리면 단다 데시제요 말이스. 야 단다 아주 데시자 야게 니츠셴다 나신 개첨부 디나 개첨부 말다 이나요 개첨부레스. 텔라야 뉴턴기 텐슈기 단장식레스.
It has a numeric value. If you measure distances in meters and you measure mass in kilograms and you measure forces in newtons, then G has this value, 6.67 times 10 to the minus 11.
게티 저런게로와 지자비 값이 지시디 슈디 뉴턴제 랑세데 아니 미터제 지세데 킬로그램 나라야 두 세제요 바인바나 스와 디세데 킬로그램 나 세제요 바이나 아니 G 아니 코게 장탄디가 소리스나 주차 주든데라야 주기 또 도마 쪽지게 좋았던 성그레스.
Now, I wrote out this whole number. This is scientific notation, but maybe you're not familiar with that yet. But I wrote out this whole number with all of its zeros.
나 강라이가 쪽이 톱기나 트야데다 천리게 지구다 천탑강 지사요로 행케디 지출을 때라 자주메 바이바이나 디카탐지데디 아니 나쪽 시장기 넘버라 지사요스.
And you might be looking at this and thinking to yourself, wow, that's a really small number.
다 데이터 스tambal아야 저런 거 알을 통과 대시달 알이 통과 되다 하천 춤춘지레샤 30그레스.
And you would be correct. That is a very small number.
다 춤춘지레 30스tambal아야 저런 거 되다 삼바에는 두바레 데 통과 되 하천 춤춘지레스.
So what that means is that in general, the gravitational force even though I'm attracted to this marker has some mass, I have some mass, we are attracting each other.
다 피샤샤 바이나 니라라 유피게 다 지가 뉴구지요와 테라야 두세초레 나라 두세초레 나라니가 바로라야 텐슈요레스 임바이나야.
But both of our masses are pretty small. And so if you take my mass times the marker's mass and multiply it by this big G here, you get a really small number.
다 나랑게 두세다 되게 뉴구되게 두세 다 두세도 하전 총총로와 테라야 단다게 지세 되게 단장대로와 되게 줄바임바네 토파 하전 총총실레그레스.
And so generally, gravitational forces are really only important when you're dealing with really big, massive bodies like moons, planets, stars, things like that.
다 제자 단단한 쪽의 텐슈게 슈제데 그 뒤치래에 전부 연구에서나 하는 쪽에 가서 뒤치를 하장 체외기 요거 비차샤나 아니 골라타부탄 테네 자크르타부탄 카르마타불라야 아니 체자바다 뒤주탄 대위 비치자 값에 아니 텐슈세데 아니 그 전부탄 개천부자고요레스.
But gravity is the force that determines the orbits of all of our planets, the roundness of stars and planets, and is the most important force in the cosmos.
다단다 이나양스와 그 준준다데다 이나양스다 단단가 속에 이나양 다 텐슈데 아니가 속에 스타스 그 자크르탄 딱 자크르라 소파게 그런 그 콜럼티 템베치니다 아니가 속에 자크르라 소파게 아니 그게 자크르탄 다 카르말라 소파게 자탄 카르말라 소파게 그가 이입지요와 어디줄라야 아니 그거 타체니 뜸세 아니 단단가서 직등 감그나니 쉽게 주시되 자기요레스.
Okay, so the first thing I wanted you to remember, or the first thing to learn, is that the gravitational force is the product of one mass times the other mass.
단다 텐슈 값을 당보체 주고 가격이요 지로지세나 텐슈데 닝유보 뉴보니 바니 뉴보니게 뒤세당 아니 그 대화요 바팅요 지로지스.
So what we're going to try to do is understand each component of this formula, and then we're going to try to apply it to some common instances where we interact with gravity on a daily basis.
다 담보데라야 가츠게 냠이나라야 코첸트리 데나라요 피기 차시데다 레레이션 헬로치 모트치 제라야 아니 데가츠 남진 소위트나 니 비츠가리요 메데다 저 카치 모트치기스.
Okay, so actually that's the easier one, the m1 times the m2. But what about this 1 divided by the radius squared? Where does that come from?
단단가서 드세치 드세 담보도 드세니 바게 jir고레사데 답디우슈도아스 임바이나이 올라야 그게 디 가르타코 바타키 란지퉁고 고고세스도아스 데드 거하네요레스.
And so that's actually a very interesting question and something that's very important in physics.
다데 그 좋아야 야포요 바강식라야 양 인컴 생각나나요 그 개첨부지간 차이레스.
This is called the inverse square law because it's divided by r, that means inverse, and it's squared, so 1 over r squared.
다데라야 그 나쪽에 r게 란지퉁 고고요와 최선데라야 나쪽에 Arrange domigi any tension segrees income senkanane.
And actually, this is all geometry. This is a consequence of the fact that we live in a three-dimensional world.
That the Karesena Yangazo Karsa that Yipsitan de Pakanshila Natso that you Chocha Sundam Chocha Suntan then being kamchila de zanwa 어디 라테니 좀비게 슈첸지레스.
So let me show you how that works, and please ask questions if you have any. So I'm gonna erase what's on the board right now. But the
단단가 쪽에 런지 도미기 단팀 아르게 런지 중기 고야 초로티 카리멘티 아니 데시자기 인스와 니팀 단다 카프로그나에 주티 습지 단데 데시자기 인스야 바로라야 치술라 it draw you pan draw downloads.
All right, let's start with a simple example. Let's say I'm going to paint the lines according to a soccer field out in the grass.
단다 피차 샤파이나기 컨셉 볼로 제사기 아니 카스고레 고게 티지오라 네 탕기 티디 아니 지야기 제스탄바이나.
I'm just trying to make it this easy to see. Okay, so there we have soccer field. Maybe we have the midline. There's some soccer goals there.
다들 가서 컨셉 볼로 게 탕디제 네 볼로 루사타 니 탕디기 기마가 고버치와 어때레스.
Okay, I'm literally painting these lines on the ground.
땅에 가르치고레스나 단다게 티데 따고 따자고요레스 따고 선택단계요레스.
And let's say it takes, I don't know, 20 liters of paint to do this.
따고 게데와 따 비샤바이나 그 라야 쯔데 땅야라 촌데 땅야라야 아니 촌 리터니 스탐바고아이나.
Okay. Now let's say I'm going to make a soccer field that's twice as big.
당아수 비슨 현대 지식에 인스타 게팅아 속에 컨셉 볼로게 세탄 데레 담니기 추아지조라 자스탄바이나.
How many liters of paint do I need to paint that soccer field?
다 바조게 컨셉 볼로게 탕데가 게타 틀라야 쯔땅야라 촌땅야라야 아니 그 촌디 리터가 쓰고 그래스. 담니기 추아요스기도 와. 40.
40, exactly. Okay, and that's because the perimeter of flat objects is just proportional to the size of that object.
다단다가 속에 가서나 단다게 티다고 레벨로와 초찬이 동 댐비깅 요보테기 다 페리미터스나 초크 차지와와 데이터 가르에서나 아니 anga 속에 요보테기 다 거기 타그랑 세지와와 데이터 안에 태간도와요레스.
So what we say is that the perimeter scales as the size.
당가 속에 디테일도와 담보데 페리미터 시스템 발라야 데캅서 쇼차도로 코나 트코르 초카스 이미지와 데체 아니 니와텔라야 속에 스케일 시스템 발라야 차체로와 데체 정도로 사이트와 어때네 뉴보데게 거기 지중 그 남발라 거기에스.
Okay, so that's a two-dimensional picture. That's a flat world.
다 데카레스나 단다게 속에 컨셉 볼로게 제탄데 초차니 동된 바로와 디스탐발로 그 레벨로와 뭐.
Okay, so I'm going to erase this now and we're going to look at a different example.
단다데 스치가 속에 비슨 현대 지식이스.
So this also works not just for rectangular soccer fields, but for circles or if you draw a circle with radius r, and another circle with radius 2r.
Dakete de tandanga zuge tushi narmuge ibiyo patsamaimba tandanga zugo gormugo gorie biorwa gorie imba ne cheg chapkres ta tanda de susho de la ya ngasuge de kasa diorwa tambo de la ya radius r che ane hajo de la ya radius de 2r de wa.
So the perimeter of a circle, the length of this line is 2 times the number pi times r.
다 단데 되게와 단데 가서 parameter set 때 매치 타고랑설 고고도와 타고랑설 고게 타겟인 세대 아니 티레스와 아니 단다게 아니 2 pi r와 2기 파일을 제때 니 체탐 피저도 청거레스.
And pi is a number that has lots and lots of digits. I only know a few of them by heart, 3.1415926.
다 단데 파이게 고게 버세치 거라데 땅가 스땅가 사지라 땅가 마포요레스 땅이 담바데 순사치 시징가 군이 티데스.
Okay, but over here, it would be perimeter is equal to 2 times 2 pi r. Well, let me write it this way. 2 pi times 2r, which is equal to 4 pi r. So it's twice as much.
다 단다 데 값인 바나 디게 치워 디게 타코랑스 데 값으로에서나 데레스 다 2 pi 2r 게 저거와 0.4 pi r is this tambala chiwa tige takoron sete chwa tige damni rishas.
And so this is the radius here, and this is the radius there.
다 chwa tige 장체 데 r 제 chiwa tige 장체 데 2r 데레스.
Okay. All right, so what we're looking at is how does the size of the boundary of an object depend on its radius?
다 단다 데 값인 바나 데 값인 바나 고게 다 타게 다 지랑세 치고와 타게 링세데 아니 고기 장셰라 간다스테와 차요메 디텐샤스.
Now we're going to do a slightly different thought problem.
다 수그 델레 티스 만도게 니탄친데 시작이스.
Let's go back to my painting example.
다 수그 단계 담보들라야 천차당하게 스트당하게 비친치고 됐다기스.
Let's say I have a dome-shaped building.
다 수라야 단다게 다 가수가 듬즈기 체가스고라 듬유기 체가 요비게 니 캄바치 요비 원도 당쇼스.
The size of this building, the radius of this building is r.
다 단다게 캄바데게 데고 듬즈기 체가 여러 듬체게 요바이 무 요바체 아니 코게 아니 가수그레 다 상체티가 레이스나 r's.
And let's say it takes 20 liters of paint to paint the outside.
다 단다게 되게 거기 칠로게로와 칠로라야 다 컴바데기 칠로라야 아니 뜻당야라야 아니 천대 리터스 담바고이나.
So I'm going to paint my building red.
다 컴바기 칠로라야 천 아마고디 당이스.
Okay. So I have to paint the outside surface of this kind of half of a soccer ball.
that day tanda de kapse ko goryi ge cheka mai ba che dumyi ge cheka wa de ge chlo la ya chun tang res ta dumyi ge cheka sena picha sena nga su ge concept polo chi ro wa concept polo chi tumbe cheka la tang sana ko ge da dumyi cheka cha go ro wa che dumzu de o de ge chlo la tang ge res.
Well, let's say that my family grows or my monastery grows, and now I have twice as many people, so I have to make my building twice as big.
Tanga nine ninety bana gombay ninety ko chir do chi ko ta nami chi chas tamalaya ko ge ta kampa ge gan la ya ta tanda ge dumzu ki che dumzu ko yo pa ge ngo yo pa te ani chir tang ba dam ni gi chir te gi che chang te dam ni gi chir tang ba res.
Okay, so now my question to you is, if I needed 20 liters of paint to do this one, how many liters of paint do I need to paint the outside of this building?
That te tanda ta chua ka res na ke te ro ke te ani kan chong te la ya ko tse tang ya la ya liter ni tamba go yo pa na chiwa te tang ya la ya sawat su go ta chiwa te la tse tang ya la ya ne tse te liter ka chu go sa res.
I'm calling on the person with their hand up.
La ba chang de chi du sa ne chorong ga song ro chi da ka chu go sa res a.
Get you.
80.
80, that's right.
Liter je chi res te to ta res.
You need 80 liters. I'm not going to paint it red because that would take me a while. But you need 80 liters of paint because the surface area of a sphere equals 4 pi r squared. It's r times r.
That the only Johnson ka res na nga chu ge ne ta dami chi ba na te ge chungu ge ja chun te ka res na 4 pi r ge rang ju tong tong cha ge res this time ba r ge rang ju tong te le ge res.
And so just to be clear, this is for a whole sphere.
Da tanda ge surface area te ju chi yor wa te ka res na nga chu ge dum zi kanza ge chungu ja chun te yes.
So if the radius is twice as big, then I need 2 times 2, which is 4 times more paint.
Ta tanda ngarangi che chang te de dam ni gi chwa yo pai na ro 2r in bai na ne rang ju chang yo chang ro rang ju chang yo chang ne ni gi rang ju chang de ka sure ni gi shi cha ro wa instant bala ya ne chong wa de la ni shu go pai ba na che wa de la ya ne ko dab shi ro wa shi ji pai na ne ji chu go yo res liter ji chu go yo res.
And so you might be thinking, yes, we know this, how does this relate to gravity? This geometric relation that the surface area goes as r squared is at the heart of the inverse square law.
Ta tanda de kashi ge sam grace nga so ge tanda de ge ko tse tang de tang ani ji ge ten shi tang de wa kari yo na sam sigris yimba na yang tanda de kap sin de she ja ti ka re sen ar ge rang jur ge tang chi do wa ar ge rang jur ge tang le bya de ani nga so ge rang do ma ge rang jur tang ge rang jur ge ani tim chi yo wa o te ge ani ko nim bu do cha ge yo res.
Okay, so now that we've established that the surface area increases with r squared, let me erase this and draw another picture.
Ta tanda nga so ge chungu ge ja chun de ro wa ar ge rang ju tang ge ngo la ya phe ge yo pa de tanda nga so ta cha yin ta tanda nga so de sub je ne yang shen da chi ge zhi jin de shi ja ge yin.
Let me draw a light bulb. There's my light bulb. Okay, so I'm going to turn on this light bulb, and it's going to give off some light, and it's going to give off light equally in all directions. Okay. So at some distance r away, this light that goes into this cone fills up this square. Okay, and so this energy emanates from this bulb and passes through this little surface. Then, at a distance 2r, that same light passes through 4 times as much surface. And so, if I were standing here, clearly this light bulb would look less bright than if I were standing here.
The getting around 2 RUS lang yu pain by na, and RUS lang vale, and Tandagi Shetoti Uti Sechatit is choice.
Okay? And so this is a statement about conservation. Some amount of light enters this cone. It's the same amount of energy. It just keeps getting spread out over a larger area. And so the intensity, the brightness of the light that you would see with your eye is equal to the power of the light bulb, 100-watt light bulb, 60-watt light bulb, whatever you buy, divided by the surface area, divided by the distance squared.
That and the intensity is in a truxety, the erg truxel and August chatty, what they Karela Raligresana, Tanda. Aniko Tampo top teacher or top teacher, top data power tirwa top de Tatela Yachong Sheto thing as what tirwa to Chicho Jacho Kangina Tirwa, what they Aniko Jachungo go with what 4 pi r ground Jutungo go, but that's some race.
And so this is for light, right? Something that we can think about. If I light a single candle and I measure how bright it is, and I move away from the candle, it will decrease as 1 over r squared.
That digger is another to Erkiku, Tandangi Chane Kitchen is that Katie Chorongi, young Lachper, young Latin, any put you Chara, Thur on Lola Yachi, Thur in Bula Chimba by Nat, Children, Rova, Capsu, and you could get Sechachi or than the Toxeti, and you could get Arg around Jutangeta, Domatan de Vigani, and Sechati Chondru race.
And so when I say that the inverse square law is a consequence of the fact that we live in a three-dimensional world, this is what I'm talking about, that the energy expands in a spherical surface.
다다다 되게 땅뽕이 가릴라요레서나 가서가 랑지 도마기 땡침치요와 되네 내가 저 초차 선dem게 숨동dem비기 직된 감지라 요비기 되게 아니고 다시 신도 지르 되시자요 스타티카레서나 다치고 니와 차비가 값으로와 니와 차비가 값을 딱고 사자마지가 차고요라 됐다면 탁세션도 거와 on the is.
This is important. Gravity follows an inverse square law. Electromagnetic force follows an inverse square law. There are many instances in physics and in nature of this inverse square law.
다단다게 니질거 독침랑 니질거 독침 지어라 니질거 독침 때문에 개청부 차고요래 스타피샤샤나 텐슈 라 니질 독침 땅땅땅 요래 티난 신게 아니 단다 티어로 가서게 로컬은 게 쉬어라 대연 니질 독침라 독다도요래스와 티난 신게 인컴 센크나니랑 좀 감게 팀망부지 아니 단다게 니질 독침라야 독다도그레스.
Is everybody, any questions on that before we move on?
무마트응어라 영아츠 무마트응어라와 마트트마 만주응어라 야티콜라 좋아요에서.
do again dana.
So yes, one question.
당보 디키네 로이르 샤마 디치마상기 디카르자. 맞아 디 카르잔다게 강바지 텐사게라. 강바 충충데 디 쳔게발라.
네네.
베친도 티. 베나 강바 충충데 기세타 레기 요바이나. 레기 우게 요바이나 라라.
네네네.
강바 디게 답직 쳐디 요발라 미터 10주게 마다에 간디나스. 거의 다다디 찌게다다나 미터 깁주고베 소리지 시기도.
네네.
What did you do?
Yeah. Can you explain the example that you used a dome-shaped house when you talk the earlier word, the dome-shaped example about painting and usually like in our natural sense, in our general sense, what we understand is if you have like twice as big the R. We think like we need twice as much as paint to paint the outside, but
you need 4 times as much.
Yes, actually it's 4 times. So can you explain that a little more detail? Because like in our general sense, we think twice, but not 4 times.
Yeah, so I drew a dome, but we could just as easily draw a square house. So let's just take one wall of a house. Okay?
단단가 단계가 수가 지야 돼 아니고 듬즈기 체가로 체 듬즈기 ngula yopi kambachila야 samtong warwa 단단히 만나가 수기 때문에야 kambalata나 디그레스와 kambalaya 아니 kamba기 가서다 kamba기 장상마 주신 유가 kamba치고로 된다나 디그레스.
So let's take a square wall that has a height h.
당가 속에 kamba로 kamba기 장라야 장식라 딱 인스로 장디기 도셀라의 h요 바이나.
Now, if I have a bigger house with a bigger wall, that's height is 2 times h.
다 게팅아 다 담보 kamba대로와 kamba대기 도셀라의 h요 바제 네 kam바 딜리 kamba딜리 치와치게 거기 도세대 2h요 비원다나.
Then I will need 4 times as much paint, right? So 1, 2, 3, 4.
다 치워들라야 장 치워들라야 쓰다라야 아니 쓰대 천디마서나 고답 시고 보여레스 고 장가 잡아는 지금 있으면 시도와.
The point is that the surface area goes as the square of the size of the object.
다 되게 그 농촌주 대야티 가르된 거에서나 뇌보직대로 왔다 ngo직게 만을 입직게 자춘지어와 입되게 자춘데 아니 그게 다 되게 랑주장당로와 랑주장당 저요는 그 진선한테네레스.
And that doesn't matter what shape the object is. If I have one object and I simply take an identical object that's twice as big, it will have 4 times as much surface area.
That capsing when I knew Bolaya Shugi, Chapashita Yomaris, new Ayubkari, Mila Chapra Yomaris. If Chiki, if Dele, and a cook, I cook a tiger on Sesicot under the tiger on Sete, Tampo Tigi, Dam Nigi Choyo Pina, and a Karsura, Hamatelaya, Kuga Yep Tigi, Chua Tigi, Jachunte, Tampo Tele, Dab Shigi Choyoris.
And so that's just a good thing to know that if you have to paint a house that's twice as big in height, you're probably going to need 4 times as many paint.
That the Netaranjaris, the Nasugi Shigwa Gachamburi was Katie Choranga Kampachigala Sitango Pache, Nikampa Sawati Gala Sitanga Tig, and Ichi Kuga Tutseti, Kampa, Tampochua Tili Dab Nigitua Yobina, Chola Tet Nag, Zeti Dab Shigma, this is that and the Hakudos.
Does that help?
The Pentosai, the Ratris. Oh, yes.
Okay, so, but this is true for spheres, it's true for rectangles, it's true for any object.
That under the by not under get you a Dumzina Chapure, and a traditional mood in the now Chapures.
Okay, so let's go back to gravity now.
That under also Telaya, Tenshulaya, Tagians.
So here is the Earth.
I think also circular is.
Then here's India over here. Here's the edge of Africa. Here's Europe. We'll color it in.
They show like Chitwate, teach it Karsa. A shock Surnamati, Sudate, Jagar, and Mats, Salayochite, teens, Africans.
All right, here's Earth. Earth has a mass ME.
That thing as a circular, the static race and ME race.
Okay. Now, just like a light bulb, you can think of gravity and other forces as emanating energy. I think that's the best way to think about it.
That under the capsule as you get tenshu said the curricula some kind of some on the craze and tenshu the any carsugureta so circular gitanta cola dinado sukurata. If dinado you choose not court, the sukola need those the chrola chapshim big any nubachi in Bilaya Samlutang Baina.
So here's R, and I can put a little mass, little m here.
That another thing I took R gets a legit, the Layang at Suget, the taking about R and Chishabaina, the Chishabaina.
And then just like the light bulb, I can go twice the distance away.
That again, I took a look the shadow, the Tonson Gani, Cheranga Jantati, and it Damila Pachimaina.
And if this Earth is emitting a gravitational, what we say, field, I'll talk more about this in a minute, the strength is smaller at this radius because it's spread out over a larger area.
That under the capsule asu curriculum and decoration, and Sikula Gani Nasugita Chapi, Tenshukarawachi or what Tenshukarawate, and it Tandage Tampotele, Nipati Capsuko, Chabiashi Choyo Zonwa, because such a Chola Tamuzon, and a cook should say the choice.
And so I literally want you to think of massive objects as kind of like light bulbs that emit a gravitational field, and it spreads out just like light does.
ni che chu ge de sam lo ta ro chi so nga chu ge nyu bo chen bo de ani nga chu lok she to tan chong ge gan de sam lo ta ani khu gan la ya ani ten shu ka ra wa chi tu sta chlo la ya chap par wa chlo la ya tram ba chlo la ya thu du ge yo pa chi la ya sam lo ta ro chi es.
And so here, the power of that light bulb is essentially given on the top. The gravitational force will be G times little m times the mass of the Earth divided by r squared.
Da tanda de ka sanga chu she to la ya pi sha bi gan ni sam lo ta pa ba na tanda de ge su ku la ge ni ngi bo te kan la the pi shu ka re se na GT M ledger and scholar game set ledger and take Koranji Parugo Partachigora, Argi Ranjitang Jurata, I Ranjitang Jurju Gobatasongo, I Ranjitang Gobatasongoris.
Over here, the force of gravity will be G little m times the mass of the Earth divided by 2r. And then we put this in parentheses and we write squared.
That 2r la yo pigini kablaya, and a tenshutical chagres and a GTM Tandagin Butigitis ledger, this colagitis ledger, and I take a cookie that tongues in a jump totical and 2r or 2r tigi and a round good buttons go this.
And so you have 1 divided by 2 squared, so this one will be 4 times smaller than this one.
That is show targeting by now so ni 2r the ranjutang and a gangati go your tin stambalaya and a tampo tele and a ko that shigi choyoris.
So it's just like a light bulb, and the fact that gravity decreases is 1 over r squared is due to the surface area of an object in 3 dimensions.
That under Karsa. A locky shed of it on Tory Gani, Tandanga Sukola get 10 shoot the Kurama, that Taran was Tambalaya quota, Arger on Jutangangola, or Atako, Chakuyo Pati, and Eko. Chaguyo pati tanda ko kete rang sete ane dab nigi choyo paina ane ko ge shutsete ane dab shigi chadugo yo pati kare sena nga so sukola ge thala chapi ge tenshu te ane ko chaptong te ane nga so chokcha sandengi ngula chekuyo palatini res.
This is a really important physical insight that this 1 over r squared law is really from geometry.
Tanda nga so ge ane tangkachi arge rangjir tangi goya gi chiyor wa tinga so rangjir ge dokchum chiyor wa rangjir ge dokchum te ngin kam send kana ne ke chambu chi chayo padang te tanda yoya te nga so yipsir palatani chwares.
Okay, so that was, we've spent an hour now, and the 2 main things I want you to take away is that the force is proportional to the size of both objects and inversely proportional to the distance between them squared.
Tanda nga so chikana tele ngoto chiya na ne chetso ge ta chi ngi guate ane ne tung ke chi shit kala na shu se te ten shu te mebo ni ge du che ge jur se la ya ane tekendo yo pata ane ko ge mebo ni ge paro ge parthak ke rangju tang tang ane dogdes gura dogma ge do yo pateres.
Okay, I'm going to erase this now.
That is subject, yes.
Not all of it. I'm going to erase some of it. I want my Earth to stay. So let me ask you a question that I want you to discuss for 1 minute, whatever, and then let me know the answer. So here's the Earth, here's the moon. And here is a small spaceship. Let me draw. So this is a spaceship. It's small. We'll draw the moon bigger.
tanda gangi te nga suge yon shok sa de scholar wa ane te phajok te teacher dawache ane ok te nga suge ta nam khala prinyu pritri yora pritri khatru de chins.
These two objects are the same distance away from the center of the Earth.
Ta ngyubo te ni cha scholar gi tewa ne jangse chipachira yores.
I ask you, which one has a larger gravitational force to the Earth?
Ta tanda de kapse tanda gi khatru chi yorwa spaceship te chunchun yuswa ane korangi scholar ne ane tawa tang khatru ni shage jangse chipa yores ne chesula draw tria de twitter chia ge draw de karin sena ane ngyubu kangi chi gangla ya scholar ge tenshu te chua de tenshu chua de nyu kangi gangla porves.
Mom. Dawagang.
Yeah, they're saying moon.
Why?
Carcinus.
This is Chambo Yoro.
This is chair is the mass chair is.
Mass bigger than Chigwaji.
Because of bigger mass.
Exactly. They both are the force is proportional to the Earth mass times the mass of the other object. And in this case, the moon is so much bigger than that spaceship. It has a larger gravitational force.
Taranjare stataga suge ta tenshu imbaina yupo sukulagi tenshu terwa ane kangi tando yore sena ane sukulagi ditse te tang yupo te ditse jurgu yorwa tins tambala te kapsa dawegi ditse te ane khatru te ge ditse le ta hachang gi choyo cha tanda te kapsa ane dawai gangla ya ane tenshu ti chop yores.
So this just says the moon has the larger force. Okay, now here's a question. If I turn on a light bulb in a room, and then I close the door to that room, I think we all agree the light bulb is still on.
Logic per logic per nu jelaya lote per ani khamba te good jab shabaina renga suge seto de dando per yo pala nga su khile jigras.
Right? If I open the door, the light bulb will still be on. Even though I'm not there to see it inside the room, it's still on.
Tanda de kapse mbana ko Shetote Persai, Rangaranga Gujapa in Namajapa in Bana, Kating Attila may pick up sim by Nayangarang Tag may pick up sim by Shetote Perior was.
But let's say I don't have the moon and I don't have the spaceship. Is the Earth still emitting something that tells us it has gravity?
Kete Tetan Nanshingi, Tenanshingi, or Kete Delaya, Tawatang, Katutin, maybe Nikabla in Banaya, Sukulani, Kulaya, Pachi, Utachi, Lugur was.
Basically, what I'm asking is gravity a result of having two masses, or is gravity something that's emitted from one mass that the other mass can then sense?
Tadangi Tria Dicare Sena, Tenshu Seade, Ane Karsugreta, Inchi Minchi Nubo and Yoboy Chigare, Yana, Tenshu Seade, Nubu Chilaya, Nubu Chimana Tilla Yopache, and it Tigi Chapsala, New Gentil Hepana till the New Gentil Hepa Bana, New Gentil Sortiagi, that Chechido Giroes.
It's a good question. In physics, we can think of it both ways. We can think of the object as emitting what we call a field. A field is a very important topic in physics.
nga su ge te ko cho ni ka ga ni ro ji na ma ndo ni ga ne sam lu ta na ko re sta ngin kam chen ri ka ga ni ba na nga su ngi bo de ge shu ke ra wa ji ga ne ko ga lo gu yo re se jing de se ja ga re ti kap sim ba na nga su ga ra wa se te ha jing ke chen ba cha yo re.
Okay, I'm going to erase this.
Okay.
And so you'll see what I'm talking about. So we know if we put a mass, m, out at a distance r, that the force is g, mass of Earth, mass of that object, divided by r squared.
Ta ge de nga su su ko lan dam la yang yu bo de se mu ju ji sha bai na ko ge ane ku ga la te pe ge shu che de ka re se na ten shu de ka re se na ji de su ko la de se la jir ngi bo de ge de se la jir ane te te ko ni ka ro go par tha te ro par tha ar ge ran je tang go pa dan song go res.
Now, what we like to think of as in physics is that the Earth is emitting some kind of a field. It's like a light bulb emitting light. And then if you put an object in the field of the light, it will, it will interact with the light. So we like to think about what's called a gravitational field.
Ta da na ngar ge ta che su mo ni sam na ka ra tang go re se na si ko la ge an ten shu ka ra wa chi ga lo ku yo pa la sam na tang go yo res. Sam na tang go yo res ta pi sha sha pa na nga su e ki ro e ge ta she to chi ki ro sheto chi lok ki sheto chi ki ti le bai bai na khu ta khasa ko le ti le parwa emba na yan tanda ki ta ke lo pa o ke lam chi la ya ne ko nyu po chi sha bai bai na ti khu chu chi ku yo pa te ta chu a te ta nyu po ti ni ko paro la yan ko ge ta de was ne de ju chi yong ko was.
Okay, so the Earth emits a field, and this field doesn't depend on this object out here. It only depends on the properties of the Earth.
Na da tanda de ge din bai na su ko la ge ko rang ge ten shu ka ra wa chi chlo la ya do sta tru lo ku yo re swa. Te ge ko ge ta ra wa te ani de la sha pe ge de se chi ro nyu bo te la ra le ga ma re. Te khare la ra le ge se na su ko la ko rang la yo pe ge che chu chi re.
And so in this expression, the only thing that depends on this mass here is this term little m.
Ta tanda de ge ro wa tanda ge de ge na ne ru de la ta bai bai na de che chon chon te tan je wa yo chu te ka re se na ne de se nyu bo ti ge de se m ro te chi ko re.
So what we usually do mathematically is we take these quantities and we put them together like that.
Ta nam jin ba na ga su ka chi re se na ko nyu bo chin chin te tan jo me chu ge chi ga cha shi chi go ra te chang ma ni cho chi la le ni nyu bo te ge de se te chi lo la ta ko ta ka chi lo don ji du su nga su cham ba chi ge res.
And we call this a field G, which multiplied by m gives you the force.
Ta tanda nga su ge te la ya ro ani ka se ge se na shu ke ra wa te la ya ji se ge ji che ani ngu bo te ge de se ge jwa tan su go res.
So Newton's gravitational constant times the mass of the Earth divided by the distance you are away squared gives you a gravitational field G.
Ta tanda ge Newton ge ko ten shi ke ten dang che ani su ko la ge de se che te te ju ro ani te la ya ni jang se ge ran ju tong go bai bai na na su ge ten shu ke ra wa chu ro ten shi ke ra wa ji te te ge res.
And then you might be thinking, but wait a minute, we've already seen this. We know that the gravitational force of an object on the surface of the earth is m times g.
되게 네탄테 레스탄발에 체초갈 속에서 알레 내가 송아사선에 뭐마츠가 하고요. 스티커를나 뉴부치가 스콜라게 토픽이 텐시티가 소리에서나 뉴부디가 되체팅가 속에 지기 줄었던 송고요.
Okay. So here I am, a person on the surface of the earth.
되가라야 다른 무지처럼 데려와 내가 스콜라게 뇌라 대요 비게 미치레스.
The distance I am from the center of the earth is, I'm going to denote as RE, the radius of the earth.
nga yosetene skolage tewaga paroge ne jansete kasre sena re skolage tandag delaya re trigins rt ne changsechi etiga earth the skola chambichis.
So if I'm at the surface of the earth, then G is equal to big G times the mass of the earth divided by the radius of the earth squared.
Ta ketirwa ketinga sukolage sangwela deyo paina ane koge degi GT kangetan songre sena ane tanda ge neutron ge tenshu ge tenjanche ane te sukolage dichelajur ane te de sukolage changshi ge rangje tong go patan songyo res.
Now, if you go and you say, okay, here's the value of G, and you look up the mass of the earth in kilograms, and you look up the radius of the earth in meters, and you plug all those numbers in, what do you think you're going to get?
Da kete tandage nga tsuge jide tangi teso jige kuga tangtangte ro wate je ane choronge kete ta thola ya che baina ro sikola ge ane 2 kilogram na ka sore do ti che ane sikola ge changche de meter ga na ra ka sore che ti che ane dus de tangka te samana chi de tsja pa ane che so ka sol hesar wes.
So you plug in all these numbers and you get 9.8 meters per second squared. And I don't know if you've been using 10 meters per second squared or 9.8, but that is the gravitational acceleration of objects on Earth.
That under those who Tangati Tonala Chichi, Churungus Japana, Hamatilaya, Kacharanjatana meter, and a good sa J, Padi, those slave grace, and it under Chichin, a good sa J. The Pichitango cigarettes, Chichina, two Pichitango cigarettes, that take a race and a Ningasuge, New Bochikangalaya, Sukola get happy, get Latin begin the race.
And so that is the field evaluated at the surface of the earth. That is where 9.8 meters per second squared comes from. It depends on the mass of the earth, the radius of the earth, and Newton's gravitational constant.
Tigatanga to Sukolagi, Nula, your pig, tension Parawagi, that's it, Swatch, it's that thing as you get any tension let them begin university, Yonyate, any neutron gear, Tenshuke, Tangente, Sukolagi, Tuselager, and it did a Sukolagi, Tanshig around you to go let name Goris.
So if I go to a new planet or I go to the moon, and I want to know what is gravity going to feel like on this planet, right? Then I'm going to say I need to know the mass of the planet and I need to know the radius of the planet.
Now, take it, any co Zakrishin that you can like Zajan that you can like Shindet and Zajan Tig on like happy cups, any Tig on like your pig and tea or Rockasa. Tako tenshu chugaro tenshu tig gala yo pig tenshu ti kanado chu yena se chorong ha kunyi to baina ti karela rale gresena ani dosa ge zate ge deseche ani sate ge ko che chang thi yo ra chang che yo ra chang che ge rang che de la rale gres.
Okay, let's stop for questions for a minute.
And other during a choose stage de ani draw talent ang jains. Draw your nationalities.
To a chick, yes.
That's all.
Tuchik the day in Tande Angzi di Shisung Chevina, Zamling Dutzi Jatugua. ME di Sukora Javina, di Tata Degrives, Angzi di Shisung Javina, Azuki, Zamling Dutze, Kilo de Yores, the Jamna Degrives, Chick, Ale to the member Chick de Garesana Dangazo, Zamling di Gogota member Ringdung Shoriona,
Ore.
the Chick Karjana, any Surdi the Tenshuk de Logareves. Gang Pena Secole Chang Chodan, Pesi Zamling Daisy, Pacho in a Yaring in a test Jojo Yosams. You did somebody that Yona, any gang did Jota Taring do short the Yona Jimala, any Jimala Kazuta Ringa Yona, Cotenshuk Jo Chagres, Jimala Tanyawate.
Uh-huh. Two questions. First one is, can you use like, can we use this formula G is equal to capital GME into RE squared? Can we use that formula to find out the mass of the Earth if we know the other terms? That's the first part of the question. And the second part of the question is, as I understand, the Earth is not exactly a sphere, and it's like kind of is a deformed sphere shape, and so that's why one side is like one side. The R is later greater than the other. So in that case, is there any differences in the terms of their gravity that felt on that area or that side?
Yeah, both of those are great questions. So the answer is absolutely. If I already knew Newton's gravitational constant, which can be measured in the laboratory, and it was by a famous experiment, the Cavendish experiment. If I know G, and I knew the radius of the Earth, I could calculate the mass of the Earth by measuring this acceleration. So the answer is yes.
Tak draw ni siya ya ko dus draw tampo de ge lente nga su ti peji tong degrees ta nga su ge ani ko ti tande ti peji tong de tong skola ge dise te sana degrees tanda ta shenda nga su ge ji ti tang te zo la ya ani keta chambo da ji chua chi oro ti sala Cavendish experiment sa chi oro sti nga su tak she kang chi de te ni ko ge ji ge rang se te ji ge tang tang te kare ba ha ko chi ge se ni shenda tu ste de te nga su skola ge dise dus
And the second question was, does gravity vary over the Earth? And the answer is absolutely yes. We actually have satellites in space that can map out these very small changes in gravity, and they use that to look at like how ice is melting on different parts of the planet and how the planet's shifting.
Tandagi ani sukolagi karsure sukolagi chukoge ayib latene dete wa ayib mandola ayu gita tis ito riri marwa tilatene dete kola ya sukolagi ani tenshuti ko ni mandola mando yore ko chepre yore snati yore ta tandai bananga su parnang kamla ya ani koge chepre chongchong sukolagi tenshu ki chepre chongchong te ko chenje nyege ta ngasuge Sonkertinda yores, ta Sonkertinda ge tseje batila tene dete, ne ngatsu ge sukola ge chukos sasho kawa ya ne chram ti shye ge shitse shi chwa dumudula sopa lu tsenja ge yores.
So those are great questions.
Drop ya dos.
Now I was going to show you guys a video real quick, and I just want to emphasize, here's the cool thing about a field. A field only depends on the properties of the Earth. That's why everything on Earth has the same acceleration.
Tadanda ndigi chela ya ngatsuge lonin chunchun tongtong shten yesti mateng wala ya ndi kolendeshi japana ni yan sembuchi kares na ngatsuga rawa se ti yan sembuchi kares ko ti karechne yan sembu yores istambala ya ta rawa se hedi sukola khugi chechula ya tengi yores ma topi shendala ralegi yo mare sukola khurangi chechula tengi yotsa sukola gangla yobege ni nyubo tsama gangla ya ngatsuge ta sukola tembi tenshu chigorwa tenshu ku nyunon chigorwa nyunon ti chikpa yores.
Okay, I'm going to bring up a video.
Tanda lonya chitengis.
Okay, and so I have to make this, I have to be able to share this somehow. Got it. I can share the sound. Let's stop share 1 second. There, and then share sound. Yeah. Okay, so you can see this full screen. So it's in English, but I can explain as we go along. I'll turn the volume. You can turn the volume down a little bit. So actually, let me explain before I start the video. So here in the United States, we have NASA, and they have a huge vacuum chamber, and they take all the air out of it. And without air to slow things down, everything should fall at the same acceleration. A heavy metal ball should fall at the same acceleration as a bird's feather.
Tata de ko tashi jabana de karesana nasa ge ko ge ta tashi jesala ani khampa chembo ji yores ta khampa chembo de ani tongsang ge khamzu yores tongsang ge khamzu sena ko na yopi ga long changma chugo tengor wa ta long changma chilo teng ba bana den de na ne ne de kare teng gore sena nyubo ta de chembo je ko so yena de kare de chong na de gore ta chembo nga cho 작게 작게 되는 지나 되거래 아니 현다 뒤에 총총 다다가 그 차도 따버지긴 바나 그 통야대 아니 निर्णय 책그 निर्णय 책 시바가는 말 한거 받았던 거래서.
So you're going to see a test of this experiment.
다 제속에 단다 아니 단다 통야대 가래서나 아니 딜라다 똑시 디 드립샤주게 sorta 지주지 통그레스.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity.
Okay, so let me stop sharing for a minute. Okay, so the point here is that if you take out all the air, all the other forces on an object, and all you have is gravity, that gravity will pull all objects down with the same acceleration.
Tanda dela koge tenge tentonte karesena ani ko nyubo gangla popi ta shushenda yoche chama ta mepertang baina swa mepertang chene skola ge tenshu chu popoche baina ne nyubo chama gangla ya skola da teni de ti chongwi ge tenshu ku nyunon chi yorwa nyunon ti chikpa chida ko chikpa chi poko yobate do sten yore te gasoresna tanda dela ten nga so gutso jele do deres.
Okay, so there's two things I want to do before the end of our first class session. First, I want to see, is there any questions?
Da nga so sonchen tangpo te matro nga la ya sandan de la ya neto ni chitani to son tangpo de la ya ne chechu sa de de tan ro chu ga draw de na yo nas.
And okay, if not, I want to ask a question of you before our break.
Ani draw me baina ni tanda nga so person matang nga la ya chechu la draw chitra yes.
I'm going to keep my earth here. So here's Earth again. And then we're going to draw the International Space Station. Something like this. Which you can actually see with your eye going across the sky. And so here is the orbit of the International Space Station, let's say. Now, if you're an astronaut on that space station, do you feel gravity? What do you think?
가리삼거두스.
설국말에
No.
춘추지.
Maybe small one. Maybe small gravity.
Well, I mean, let's say you're twice as far as the radius of the Earth. So gravity's reduced a little bit. I mean, that would be really far. The International Space Station is much closer. But gravity's still there.
Tanga suge jishi kayam babsiti kete tanga susukulagi chanshige dabni do chilo yo paina chitang tenado yo maras chitang this tanyo yo res wa tanyo yo chang ni tenshu ti tandong bane yo res.
And so then the question is, why do we feel weightless when we're in space?
Can you repeat that again?
Why do we feel like we have no weight when we're in space, like an astronaut?
Dadadi kapsa tenshu yo pares kola tembe tenshu yo pares imbai na yang tanga su kayang ka babsula danyi ka koso serupa koso ge ninga su ga jime choya chorwa weightless korwa nga su jitse mepa ga choya chida chorwa ti karachine legu yo res.
And so what we're going to do is we're going to start the beginning of the next session talking about weightlessness.
네 지마팅 고마츠고라 nga su tanda jime ground jitse mepi ga choya chorwa jime ground ti la de sijakins.
So thank you for your attention. I think we can take our half an hour break now.
Yes.
Yeah, it's about 10:30. Good.
Laso ne tuches tanda nga su chekage person tangi